go through the distributive property section with you guys, okay? So this one is all about one property. So the previous section, you learned about multiple properties within one, but now we're just going to focus on one property. So what is the distributive property? Hopefully with the previous activities, you were able to come up with it on your own, but if not, let's take a look and see what it is. So basically what it's saying is if I have 3 times 7 plus 2, in the past, you can just add 7 plus 2 and do 3 times 9. But now we're going to be substituting that with variables. And we're also going to be able to use that to help us do mental math faster. So the way I do this is I think of it like distributing papers. I'm going to distribute the 3 to the 7, and then I'm going to distribute the 3 to the 2. So I'm going to do 3 times 7 plus 3 times 2. This now is 21 plus 6, which my answer is 27, which makes sense because 3 times 9 is going to be 27. If I substitute 3 for A, 7 for B, and 2 for C, that's how I start my distributive property, and that's going to be equal to AB plus AC. Okay, so that's my distributive property. A gets distributed to B, then A gets distributed to C. This could also work with subtraction. So if I had AB minus C, it's going to be AB minus AC. So the only thing that changes is the subtraction sign, but yet I'm still distributing. So let's look at example 1. Example 1 is a nice use of mental math to be able to figure, or not mental math, but quick math, to be able to figure out how to use the distributive property to your advantage. So let's take a look. It says use the distributive property to find 8 times 53. So before you did 8 times 53, you set up the problem, you did the math, you got your answer. But if I do 8, if I split up 53 into 50 plus 3, I can do 8 times 50 plus 3. I know this is going to be 8 times 50 plus 8 times 3. And all these numbers I can do in my head. 8 times 50 is going to be 400, and 8 times 3 is going to be 24. So I have 424 as my answer. This is a nice quick way to be able to do mental math, well, not exactly mental math, but be able to do it without having to do the 53 times 8 and do 4 and 24 and 424. Okay? So it's just another way to think about it. All right? Especially sometimes you can do it pretty quickly. The second example deals with fractions, and I know how much you guys like fractions. So let's take a look. First of all, we're doing 1/2 times 2 and 3/4. All right? So I know 2 and 3/4 is really like saying 2 plus 3/4. So if I rewrite it that way, I can say 1/2 times 2 plus 3/4. All right? 1/2 times 2, which you can definitely do that in your head, and 1/2 times 3/4. Half of 2 is 1, and half of 3/4 is 3/8. So 1 plus 3/8 is 1 and 3/8. So it's a nice quick way without having to switch your numbers into improper fractions. At this time, I'd like you to do the on your own problems at the bottom of the page to get a little bit more practice on this. Okay, let's go over example number 3 now. Example number 3 has some more problems using the distributive property in its classic form. So what happens when we don't have concrete numbers, okay? What I mean concrete numbers is what happens when I don't get a for sure answer, all right? What happens when I have a variable? So let's look at A, example 3A. 5n plus 5, well, or 4 times n plus 5. You read this as 4 times the quantity n plus 5, so just in case you need to know how to do that. I distribute the 4 to the n, so it would be 4n plus 4 times 5. Okay? I can do 4 times 5, so this is going to be 4n plus 20. This is its final form. N is not a like term with something without an n, so that's my final answer. Okay? My next problem, I'm going to distribute the same way. 12 times 2y minus 12 times 3. 12 times 2y is just really going to be 12 times 2, which is 24y. minus 36. I'm done, okay? And that's the final answer, okay? The last one, I'm going to go 9 times 6 plus 9 times x plus 9 times 2. Now this one you may have to use more than one property to solve. So the first one we use is the distributive property. Okay? Then we're going to combine like terms. So this is going to be 54 plus 9x plus 18. You can say you combine like terms. Now I notice this 54 and the 18 are like terms, and I'm going to put them together. So 54 plus 18, the way I can get that 18 by the 54 is by the commutative property. 54 plus 18 plus 9x, and this is going to be because of the commutative property. Now 54 plus 18 is going to be 72 plus 9x, and this is, you can say because of adding or like terms, and there's your final answer. Okay? At this time, I'd like you to pause the video and do the on your own questions after example 3. The last example we're going to go over is example number 4. Let's see what example number 4 says. Jose is X years old. His brother Felipe is 2 years older than Jose. So we know if Jose is X, oops, oh no. So if we know Jose is X, we're going to put Jose is X. Felipe is 2 years older than Jose. So Felipe is going to be X plus 2. Then their Aunt Maria is 3 times as old as Felipe. So let's say that Felipe is X plus 2. It's going to be 3 times X plus 2 because X plus 2 is what Felipe is. Write and simplify an expression that represents Maria's age. So this is what we're going to start with, 3x plus 2. We're going to use the distributive property. So we have 3x plus 6 because of the distributive. Actually, I went one step too far. Let's do 3x times 3 times 2. This is going to be because of the distributive property. Then 3x plus 6 because of like terms or multiplication. Then that's going to be our final answer for Maria's age. Okay, that's as simple as I can get it. All right. Now I want you to think about what if Jose was 10 years old. We want to know how old Maria is. So all we have to do is plug in 3 times 10 plus 2. I'm going to use the distributive property. 3 times 10 plus 3 times 2. So it's going to be 30 plus 6. Maria is 36 years old. Okay? I'd like you to pause now, do on your own question after this. Okay, the next example, example number 5, is going to talk a little bit more about like terms. So it's something that I have been talking about over and over again in these last couple sections. So we notice that anything that has the same variable is a like term. Anything without a variable could be a like term, or anything with the same power variable. So for example, 3x squared plus 4x squared could also be like terms. This is going to equal 7x squared. Okay? So let's look at this one. We know 3x and 2x are like terms. All right? So let's see how we can get that 2x there. So we want to move the 2x. So it's going to be 3x plus 2x plus 9 minus 5. This is going to be the commutative property. Okay? Now 3x plus 2x is going to be 5x. And 9 minus 5 is going to be 4. I'm just going to cut to the chase and say this is due to like terms. Okay? So if you notice that I can do 3x plus 2x here, and I can do 9 minus 5. Now let's look at the next one. Y plus Y plus Y. Now, I told you in the previous section, there's really a 1 here. So I really have 3 Y's. That's combining like terms there, okay? It's talking about in the book using distributive property as 1 plus 1 plus 1 Y, but you don't have to do that. You can just use math and saying because of like terms, it's 3Y. And the last one, you have to use a distributive property here. So 7Z plus 2Z minus 2 times 5Y. That's due to the distributive property. Now we want to combine some of these like terms. So I have 7Z plus 2Z minus 10Y. Z and Y are not like terms. So this is, I'm going to say this is due to like terms and multiplication. Okay, now 2Z and 7Z are like terms. So this is going to be 5Z minus 10Y. This is going to be your final answer. This is due to like terms. Okay? At this time, I would stop and simplify the expression 11 and 12. Hopefully this helps clarify some of your concerns that you had on this section. Hopefully you get all the examples. If you have any questions, let me know. I'm going to have to think of a cool sign-off. If you think of one, let me know. But feel free to ask me any questions that you have, and hopefully you have a good day. Bye.